Oh, sorry. Oh, excuse me. Oh, so I'll just be presenting something about network security and how you can segment your networks, ensure that your firewalls are properly placed and configured with the basic setups that we can do for a very effortless, cost minimized way of reducing the attack surface and the ability for attackers to get through your networks. These network security and network segmentation is very standardized and can be provided by you from several guided books, CompTIA Plus networks, or any other books that are credited and are in the realm of network security. You also can hire somebody, a specialist, to ensure that your network is configured correctly and will disallow people with certain intentions, bad intentions, to get in. So let's get going. Let's look at some networks here. So actually, this is just from the presentation. I will go through the different layers here. We have 7 layers in our network. So when we talk about these, about networks and connections and the interconnected world of things and computers, we must somehow logically separate the different kind of data or connection that goes through the internet. So the way we do this is by saying that we have 7 different layers. We have the physical. We're starting from the bottom actually. So physical, this is the cables, data link. Well, this gets more into who connects the ports of and the ends of the cables, the network. Well, this is multiple connected ends and transport. Well, now we're talking more about what is going, how it's transported through these connected, and how are these different kind of nodes that we call them in the network, how should they communicate with each other and what protocols should they use. Then we have the sessions. This is more about when we have a connection we have agreed upon, then what can we do, different kind of things we can apply that will make the session applicable or in a certain way that we want it. We want probably restrict or allow certain things. Presentation layer, well, this is more or less just going up to the application layer. So let's go into deeper. Application layer is for the actually communication of software or packets that are applications that. So this is more like UI stuff and everything that goes around with it. So, for example, when we talk about networks, well, application, that could be what we need to know or what we need to do when we have networks. Well, we can inspect these different kind of layers, and then, because if somebody wants to attack you, imagine you have a PC, I have this MacBook. Well, I want to be sure that when they are trying to attack me, the only way they will attack me is eventually through the network. So, in principle, what we need to ensure that is we inspect what comes in, what goes out of the on the cables and the network. So if we talk about NGFW, well, that's short for next generation firewalls. These are able to, on the application layer, so that's actually very specifically looking at what is happening in the application, and that gives you it's like a microscope going in like this. But this also is an expensive solution and only advised to do if you have the need and the resources to implement this. Yeah, so it has really the application layer. Well, for us, it's interesting, but it's costly to do network inspection there and set up some kind of firewalls there to guard against somebody who is misusing the network to get into you. Presentation layer, well, there's several different kind of things here. So there's something called TLS offloading on firewalls and proxy. I'm not particularly sure what they are, but I'll just mention them here. They are not as important as if we go down to the session, because session layer offers us VPN, SMB protocols that we can use to secure our network, secure our communication, and we can filter and we can monitor and we can prevent users from using VLAN and server VLAN. So that's handy. The session layer here is more useful and more. It should have more attention here. Going down to the transport layer, well, transport layer here is very interesting, because that's the TCP protocol that's going on here, and UDP. And TCP are fundamentals in our way of connecting. So TCP is where we require some three-way handshake. So we through the connection, and UDP is more like just sending stuff to nodes in between on the network. So here is stateful firewalls applied. We have access control list, we have intrusion detections, and we have IP intrusion prevention systems that operate on this layer. So this is all these layers are required in a communication, but the transport layer is a very effective way it's an effective place to implement these kind of things. So the TCP, UDP, and microsegmentation is very relevant when we talk about security in terms of networks. Let's continue on. So let's look at the actual network layer here. So transport layer, network layer is there. We can do some subnetting, we can do some layer 3 switches, and we can do some source destination IP inspection and disallowance. Data link layer, well, we can isolate VLANs here, we can prevent broadcast sprawl, local traffic leaks, and lastly, on the physical layer, we have some air gapping. That's very this is very restrictive. So air gapping with separate cables, so that is like not allowing any connection into certain areas, not connected at all. And this is for high security zones. So yeah, so the lower you get on the layers, well, the more like physically you restrict more communication. So if you want to monitor, if you want to inspect good communication and look for patterns, bad communication, well, you're operating on the upper layers, application layer, session layer. But if you and applying encryption, but if you're restricting more more adversely, or you would be implementing stuff, firewalls, etc. on the lower layers, and so that's a way of looking at it. And this is more technical networking stuff, and this is more software development application layer. So here we have some servers in our organization. So we have chosen to make these segments here. So we are separating these in different kind of CEDAR notations, and different kind of IPs. This is a way you should get a network professional to do with the network. And this because this can be configured out of the box without buying extra gears, presented from the router and switches. Not very costly, but adds a lot of security, a lot of transparency, knowledge into the system, and control. So you will eventually allow connections through this switch to the your router to the switch and connect to the segment. So you have one segment connecting to the internet, you have another connection through the router to your ISP, your internet provider. Then what should come as a natural thing is to, in case of two segments here, you will apply a firewall between your ISP and your router, and you will apply firewalls into your critical systems here. So we have a critical system here of our dev development environment here, servers. We enumerate them on the VLAN 060, and we have a demilitarized zone, so VLAN 020, and this demilitarized is more accessible. So we are less restrictive on what is going on here. But in the dev server, we need a firewall blocking these servers. And what we'll also do is that we will we have IP addresses to control on the IP layer, to control communications on the network here. So we have first of all the router with the IPv4 address, and then we configure the switch here, layer 3 switch on the network, so to have its own IP. And this IPv4 address is, then we have the CEDAR notation. So we will eventually restrict, as we see here, the IPv4, or we will apply a certain address space in this segment here. So this segment will, and then we will apply this, the higher we make the stash on the IPv4, the less servers, the less IP address we can hand out to whatever who needs that within this segmentation here. And we also have the subnet mask telling us actually when it goes up to 255 here for each one. So this will eventually allow for subnets that are so we plus 3 so we have eventually 8 here on the subnet here that can access, or servers that can be created here in the dev servers. So these are critical. This is very critical. So therefore we must restrict. We must have this kind of notation here for the dev server environment here, because that will eventually prevent some possibilities of attacks of servers not being allowed to be created in here, so and accessing this network. So this is a cheap way to restrict the networks. On the other hand, we have this demilitarized zone, DMZ, and this we see the number here is lower, so it eventually allows more. So if you subtract this from 255, we get a higher number than here. So this is crucial for building your network and segmenting your network. With demilitarized zone, we allow more components, more servers, more phones, more IP addresses, because every instance needs an IP address to communicate with the rest of the network. But here we restrict it very much. We have very few allowed to connect to the or be in this network here, segmentation, to get to be allowed to have an IP address with this address namespace. And then we protect, of course, this with a firewall that adds extra protection from the in addition to the boundary firewall, and then we don't have any firewall here. So this could be our and we could have a stateless here, and we could have a stateful down on the into the critical stuff. So we can eventually inspect more things here. It can look for connections that are established, and then it can disallow certain kind of communication on these connections. We'll get into more of that. So here we have stateless at the perimeter, and we have a stateful for the internal firewalls. So let's just have a cup of coffee here, a sip of coffee here with my lovely pink coffee cup. So I don't know if you remember anything what I said, but you can perhaps try to name some of the components. So what some of the buzzwords or keywords here that I was talking about. We could so you could pause the video and then think for yourself. Try to remember what are the different kind of what should I at least be aware of here in the system here. Concepts. So one concept could be, if you are ready, well then it could be subnet masking. So subnet masking allowing what subnets do we configure our routers to have, or switches, and thereby allowing only certain nodes to connect to this, or like computers, servers. We have the segmentation. So segmenting is important to also disallow components on the network and having IP addresses. And then we have the firewalls, stateful and stateful or stateless. So if we go in here, we look at the stateless firewalls. Well, then we look at the transport and network layers. They can able to block here. So when we want to configure these, we can configure these in different kind of way. I'm not going to go through the technical configuration here, but you could hire people professional or request a video. I will be loving to go into that, because you have the way you will configure a stateless firewall in Linux, for example, is first assigning a ID. So we could P1, so policy 1. So what should our action be? Well, our action should be allow. So we will allow certain things here. So that's actually easier than so perhaps we will start by denying everything, and then we will allow certain stuff, because then we have like not a huge black space of things that are getting in here. So we can configure the source IP. So which IP should it be connecting from, and what IP should we allow, and then to what server. So the server it could connect to here. So we have a server here with web 1.192. So this is perhaps in our demilitarized zone. So we allow a connection to the internet going into any. So let's say here any. So when we say any, we have the internet as the source IP, and then we have the web 1 is our destination IP, is our server, internal server, and this is behind the stateless perimeter, so it's a demilitarized zone. So we will allow anything from above 123 to connect to and to the destination port 443. So this is our destination port. So this is the port we allow from our web server to be connected into for clients looking into stuff, perhaps a web page or something that they want to browse, and they want a web server that wants to access some kind of details, products, catalog or something, or other details. And we allow the protocol TCP, we configure the TCP protocol. So here we have the stateful internal firewall, so perhaps the P1, perimeter firewall, and internal is IO2. So we have a rule 2 in this stateful firewall. Well, we'll allow something, and we will allow the, so this we should be aware of. We cannot just allow any connection here from the internet. So we'll be more careful here. So we will allow a source IP from the dev VLAN. So we have perhaps the dev servers need to connect, the developers need to connect to the dev servers. So we will allow a certain source IP here from this source IP range here with this notation here to come into our dev server environment. We will allow a destination on the dev servers to be connected to IP address, and then we will allow any ports to be connected to, and we will allow any destination port from and to. And we will then here's the extra part that we add from the previous one that we did for the web server. So as I told you before, we need to there's these two are different kind of in the setup. So stateful adds more than stateless, and stateful will enable the possibility of stating, well, is this connection new? So we'll allow a new connection getting in. So, and we can have connections. So we can have rules for what kind of connections do we allow, and what kind of specify what kind of TCP ports they're allowed to use, what kind of ports they're connected, and also if they're already established, we can also state established. So if there's some kind of established connection, and we see we wanting to avoid some UDP in this established connection, well, we can make a rule for that. So we will in this stateful firewall, we'll make a default drop. That's what we were talking about before. So we will eventually need to drop everything because this is high security. So we will only allow what is going in. We will not allow anything else to get in that we don't know of. So we will best practice is to add default drop. So the action should be deny. The source IP should be any. So we're dropping any connection, destination IP any. And we are source port. We are not allowing to any source port, any destination port. So here we're adding maximum security as a default drop, unless if it goes through. So we have the rules are on top of each other. So it will eventually So the way it works is that it will, like an algorithm, it will go through each ones that if we define them on top. Visually on top before the deny drop, then it will check if it's the dev servers calling in to get a connection, and if it's not anything that's allowed, it will drop it. Very useful, very useful. So the state is just any state. So here you will actually see here we can inspect, as I was talking about. You can see that we have deny any. So, and we have some kind of different kind of. So this is generic examples. This is not specifically to the one I showed you, but this is more or less showing into it. And I know you can just pause it, look at it, and just trying to figure out for yourself, like looking at, here we see some action that is allowed here. So this is eventually establishing the connection from the source to the destination, and then the other way around. And then you can configure rules here. So for example, here you will allow certain kind of UDP connection, so this is, you can like group these two, so for like the same use cases. So here you are like restricting a certain IP address to connect to certain kind of ports, destination ports on the system. So, and then you're also defining that they are not, if they're not this specific connection, well, they are not allowed to do that. So again, restricting everything else, because internet is going crazy. It's very difficult to control. So this was my presentation here on my network. I hope you found it useful. I hope you have some improvement for me. So think of ways, stop the movie, or something that I could improve this presentation, and please let me know. And I was very glad that you would like to watch this video. And so if you think it's, please respond in kind of way, like, comment, or follow me on LinkedIn, here on YouTube, and I will see you again around in my other videos. So thank you for watching.